Number 22. Most barium compounds are very poisonous. However, barium sulfate is often administered internally as an aid in the X-ray examination of the lower intestinal tract. I will save you the visual, which is figure 15.4. This use of barium sulfate, BaSO4, is possible because of its low solubility. Calculate the molar solubility of barium sulfate and the mass of barium present in 1.00 liters of water saturated with BaSO4. Okie dokie. So, since we're talking about solubility and saturation, we're basically talking about how this compound, barium sulfate, is going to dissolve into its ions in a saturated solution. That means that we need to know its Ksp value. So I went in the back of the textbook to find out what the Ksp is of barium sulfate. We wouldn't be able to answer this question without it. But remember, all Ksps come with the balanced equation. We gotta write the one that goes with barium sulfate. So here we go. BaSO4. That's going to start off as a solid because the solid is going to dissolve into its aqueous ions. And double arrow because we're talking about equilibrium, K values. And the two ions are the barium and the sulfate, right? SO4s, they always stick together. The break would be between the barium and the sulfate. Now there's a couple of ways to find the charges, right? Barium is in group 2 on the periodic table, so it's always a +2 charge. And sulfate, always just easier to memorize those polyatomics. This is always a -2 charge. They're charges, so they're both aqueous, and it looks like the equation is already balanced for us, so goody. Now what I'm going to do is I'm going to take this equation and just write the general Ksp formula. Just know that it's always just equal to the concentration of the products raised to their coefficients. So, and actually, maybe I'll bring this down a little bit. Okay. So Ksp equals the concentration of the barium, 2+, times the concentration of the SO4. Now, just for practice, remember, it's always raised to the coefficients. But for both of these, I don't see any coefficients, which just means that there was one of each. So you could raise these both to the first, but that's the same as just not having it. So it's easier this way. Now let's start plugging things in. The Ksp value is the one that we found in the back of the textbook, 2.3 times 10 to the -8th, but I don't have values for the barium or the sulfate. So that's when I go back to the equation and I just plug it in as variables. So we say basically that I don't know what the barium concentration is. I'm going to label it X. And it has to correlate with the coefficient. So technically this would be 1x. But 1 times x is just x. And you got to do the same thing for the sulfate. It's a 1-to-1, so the variable should be the same. And it would be 1x, but just put the x. These are your variables for what you're going to put into the equation. So the barium is x, and the sulfate is x. So, let's see. 2.3 times 10 to the -8th equals, we have x times x, and x times x is just x squared, right? So I could just erase this and put a square. Maybe I'll get rid of these. And then all we'd have to do is just do the square root. Okay. So let's get that number. Square root of 2.3 times 10 to the -8th. I get 1.5. Technically, I guess we'll do 3 sig figs. Does anybody really care? I don't. So if we did 3 sig figs, 1.52 times 10 to the -4th. And that's molarity. Now just know that when they're asking for the molar solubility is always the molarity of the starting compound, which is the barium sulfate. But just use your ratios. Remember, there was only one barium sulfate, right? There's only one barium sulfate here. So just pretend that this was a 1x. So this is the molarity of the barium sulfate that's going to dissolve, and that's what the molar solubility is. So we answered the first question. What's the molar solubility? 1.52 times 10 to the negative fourth molarity. Now we just need to find out what that mass of barium is presented in 1 liter. Okay, well, also keep in mind that we'll take it from here. If they just want the barium, that's coming from the barium 2+, right? That's the only one of these that only has the element barium. And remember, at equilibrium, barium was also X. So barium also is this value. 1.52 times 10 to the negative fourth molarity. But we want the mass. But just know that molarity, remember, molarity can be written a little bit differently. Molarity can be written as moles per liter. But I think the easier way here is to just use the molarity formula, right? I have a molarity. They gave me a volume. I can use molarity equals moles divided by liters. The molarity value, we know. The liter value we know, so we could find out a mole. And if we just manipulate this equation, basically it would be moles equals molarity times liter. So I could find out how many moles of barium I have. I'm getting closer. So it'd be 1.52 times 10 to the negative fourth molarity times 1. So I just showed this to you just to show you the math, but in essence, it doesn't even matter, right? Because this was just the molarity value, and then this, we'll do this in blue. This is the liter. So the moles is the same as the molarity, 1.52 times 10 to the negative fourth moles of the barium. Okay, so now all we have to do is just go from moles to grams. How do we go from moles of barium to grams of barium? Well, we could do the shortcuts here, right? Moles to grams, all you got to do is just multiply by the molar mass. So I go on the periodic table, I find out what a barium is, and barium is 137.3 grams per mole. Let me just pull this out. There we go. So all we have to do is just take the mole value and times it by that number. So 1.52 times 10 to the negative fourth times 137.3. And I get 2.09. Actually, I won't put it in scientific notation. I'll say 0.0209. And that's how many grams. Whoop, I don't like that color. I like this one. That's how many grams of the barium. And those are your two answers. So molar solubility, grams of the barium. They didn't specifically say if they wanted the barium ion, the Ba2+, or just the, barium as just an element, but either way, you will still get the same answer. All right? So I really hope this video helped you out on this question. Let me know in the comments. Love talking to you guys. And subscribe to the channel if you want to help us out. I hope you guys are having a great day, and I will talk to you soon. Okay, bye-bye.